In this video, I am going to cover with you the implicit functions in derivatives. So right now we have been applying the differentiation to the functions when there is being expressed in terms of another. Like if we have x bar x is equals to 3x square minus 2x minus 1, right? So here it is clearly shown that function is in terms of x, okay? But now what happen if there are more than one function, right? For example, we say if there is x square plus y square is equals to 5. So you can see here that there are more than one function. Means x square is also there and y square is also there. Now the question is, how would we take the derivative of this? Now, in order to do it, what we do, we need to use a technique called implicit function or implicit differentiation. So, what is that technique? So, let's learn this now. So, basically, implicit function means when you cannot express one function in terms of other. Okay, or we can say that it is not possible to show either x or y in terms of y or x respectively. Let me clarify you this with the help of an example. Suppose we have x cube plus y minus yx square is equals to 0. Now see what I will do. If I'll take this x on other side, I will be left with y minus yx square is equals to minus x cube, right? Now if I will take y as a common, what I will get, 1 minus x square is equals to minus x cube, right? Or I can say I will get it as y is equals to x cube upon 1 minus x square. So this I can say, yes, this is a, here y is a function of x. But if I take another example like x cube plus y cube plus 3axy and this is equals to 0. So what is this? Either I will go for, I'll take y common here. So I have y square plus 3ax is equals to 0. If I will take this x cube on other side, I am left with y plus y square, y into y square plus 3ax is equals to x cube. So in that case, if I take this variables on other side also, I got y square plus 3ax. So in this case, I may not be able to express y in terms of x, right? So basically, a function x or y is, we call it implicit if it is not possible to express it in one terms. Fine, I am not able to express y in terms of x because y is also here. So this is the case of implicit function. So basically, when we have to find the derivative of function y with respect to x. So what I will do, I will take its derivative. It here means any value. Its derivative with respect to x, with respect to y, multiply by dy by dx. Okay, let me clarify this. Suppose we have to take the derivative of y5 with respect to x. What I will do, I will write it as d by dx of y5. So if we will have to take derivative with respect to x and here I am taking y. So in this case, if I take derivative, it become 5 by 4. But this is only possible if I will take derivative with respect to y. So I will write here as dy by dx. Okay, let's take one more example. Like if it is given that we have to take derivative of log y with respect to x, right? And I know that the derivative of log y with respect to y is 1 by y. So I will multiply it with dy by dx. In the same way, if it is given x square plus y square, and I have to take derivative of this with respect to x, okay, with respect to x. So what I will do, I will take derivative of x square plus derivative of y square. It's easy to take derivative of x square with respect to x. It will shift, it will comes to 2x. But if I have to take derivative of y square with respect to x, in that case I will write 2y into dy by dx. Simple. I hope the concept is clear. Now let's take some practical questions. I'll take very basic question for this. If it is given x cube plus y cube is equals to k cube. I will take differentiation on both sides. What I will get, d by dx of x cube plus d, and it is with respect to x, okay, d by dx of y cube is equals to d by dx of k cube, right? This k is constant, and so we know the derivative of a constant term is equals to 0, and derivative of x cube with respect to x, again it is very simple, it is 3x square. But derivative of y cube with respect to x, it is 3y square into dy by dx. Okay, now next is I will take this 3x square over this side. What I will get, 3y square into dy by dx is equals to minus 3x square. And if we see that these two are, there is multiplication sign in between these two, and if we take it on other side, what I will get, derivative of y with respect, derivative with respect to y, it gives me minus 3x square upon 3y square, or I can write it as minus x square upon y square. Okay, so this is my solution. Let's take one more question. Root of x plus root of y is equals to root of 3. So if it is given, find dy by dx, right? So in that case, I will take differentiation on both sides with respect to x. Derivative of x plus derivative of root y with respect to x plus derivative of root 3. Now this is what? This is constant. So it gives me 0. And if I take derivative of root x with respect to x, it gives me 1 by 2 x power minus 1 by 2 plus it's 1 by 2 y power minus 1 by 2 into dy by dx. Okay, or I can write it like this, that 1 by 2 root y is equals to minus 1 by 2 root x, right? And here we have dy by dx also. So the value of dy by dx is equals to minus 1 by 2 root x into 2 root y, or I can write it as minus y by minus x, right? So this is the case of implicit function. So in this way you may able to solve n number of problems.